Looks like we have some dice. So let's see how this works. This says we have a standard die. That means it's 6 sides, 1, 2, 3, 4, 5, 6. It's a cube. What's the probability that we will roll a 4? This is pretty simple. On the die there's 1 4. So we have one possibility, and there's 6 total possibilities because there's 6 sides. So it's 1 and 6. Pretty simple. Let's look at the next one. What is the probability you will roll an even number? Well, on a standard die, there's 6 numbers, and the even numbers are 2, 4, which we can't see on this picture, and 6. So there's 3 even numbers. We have a total of 6 possibilities, so it's 3 out of 6. We can simplify this. We can divide both numbers by 3, and it becomes 1 and 2. So we have a 1 and 2 chance of getting an even number. Again, pretty straightforward. Example 3. What is the probability that on our standard die we will roll an odd number or a 6? So either one of these things is okay. The way I like to look at these is just think of all my possibilities. I have 1, 2, 3, 4, 5, and 6. I just go through these one by one and see if they fit one of these categories. So 1, that's an odd number, so that's good. 2, it's not an odd number, and it's not 6. So 2 is out. 3 would work because it's an odd number. 4, not odd, not a 6. 5 is an odd number. 6, not an odd number, but it is a 6. So 6 is okay. So altogether I have 4 that work out of a total of 6. Again, I can simplify this. I can divide both numbers here by 2, and I get 2 out of 3. So I have a 2 in 3 chance of getting one of these numbers. So that's how that works. Now we can get a little more complicated when we get into what are called independent events. And independent events are things that, they're events we have to combine their probabilities together, but each event is separate. They don't affect each other. So here we have a die again. What's the probability we will roll a 4 and then a 3? Well, we know the probability of getting a 4 is 1 out of 6. And no matter what we roll that first time, if we get our 4, if we get something else, we're still going to have a 1 in 6 chance of getting any number the next time we roll. So our chance of rolling a 3 would also be 1 in 6. Because the probability of rolling a number on a die will always be the same. It's not going to change no matter how many times we roll it. So now to get our total probability, what we do is multiply these fractions together. When you multiply fractions, you multiply across the top. 1 times 1 is 1. Multiply across the bottom. 6 times 6 is 36. So we have a 1 in 36 chance of getting a 4 and then getting a 3. Next example, what is the probability we'll roll 3 5s in a row? Same concept. The probability of rolling a 5 is 1 in 6. And we want to do that 3 times. So we have a 1 in 6 chance every time. Apologies to anybody who's superstitious for the numbers on the bottom here. But we'll just do the same thing we did above, and we just have more numbers. So we'll take 1 times 1 times 1, which is still going to be 1. Multiply these 6's together, and that will give us 216. So not a very good chance, but that's our probability of rolling 3 5s in a row. So that's how independent events work. The number of outcomes doesn't change. It's always 6 on a die. And then we just have to think, well, what are we trying to roll every time? And, you know, on this one, we're just rolling for a single number, so it was always just a 1. So let's try this. Let's try a few of these. So you can pause the video and try these 4 questions. Okay, hopefully you have answers for those 4. If not, you can go back and finish those. But let's go ahead and move on to what are called dependent events. I don't know what. There we go. Okay, a dependent event, that's where one event, the probability of one event affects the probability of the next event. So let's look at this example here. We have a bag containing marbles. And it has 3 orange marbles, 7 green marbles, and 6 purple marbles. So the first thing we need to do is add those up and see how many marbles we have. So we take 3 plus 7 plus 6, and there are 16 marbles. So that's important because that's going to be our bottom number. It asks, what is the probability you will draw a purple marble, and then without replacing it, draw an orange marble? Well, our probability of drawing a purple marble will be 6 out of 16. And then what's going to happen here is we've taken out a marble because it says without replacing it. We're not putting the marble back. So now we have 1 fewer marble. So now our total of marbles is 15 because we took 1 out. So the probability we'll get an orange marble is going to be 3 because there's three orange ones in there out of 15. So we'd multiply these together. You can do that now, but I would rather simplify my fractions. So I'm going to rewrite this. I'm going to simplify this. Both of these numbers I can divide by 2. 6 divided by 2 is 3. 16 divided by 2 is 8. Both of these numbers will divide by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. So I didn't have to do that, but this just gives me a lot smaller numbers to work with. And now I can take 3 times 1. I can take 8 times 5. That's 40. So I have a 3 in 40 chance of drawing a purple marble and then, without replacing it, drawing an orange marble. I'm going to go ahead here and make this into a decimal. That is equal to 0.075 or 7.5%. So I have a 7.5% chance of getting that combination of marbles. Similar problem here, except this time it says, what's the probability we draw 2 purple marbles in a row? Well, we know one purple marble is 6 and 16. For that second purple marble, we only have 15 marbles because we took a marble out. But the marble we're taking out is purple. So now we look at our purple marbles. If we started with 6, now we're down to 5. So we have 6 out of 16 for the first marble, then 5 out of 15 for the second one because we took a purple marble out. Again, I'm going to simplify my fractions. We know the first one is 3 over 8. Here, 5 and 15, I can divide both of those by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. You may remember a trick. If you have the same number on top and on bottom of fractions that you're multiplying, they will cancel each other out. So that leaves us with 1 on top and 8 on the bottom. And if you didn't know that little trick, you could go ahead and multiply. You'd get 3 over 24, and then you could simplify it. And then again, I'm going to divide that out, see what my decimal is. It's 0.125 or 12.5%. All right. Another example, this is now we have a bag containing tiles like Scrabble letters, and they spell the word algebra. So we have an A, an L, a G, a E, a B, an R, and then another A. What's the probability that we'll draw an A, then without putting it back, an L? So we look at the total number of letters. I'm counting 7 letters. And the probability of getting an A, well, I have 2 A's. I've got this one and this one. So it's a 2 in 7 chance of getting an A. I'm not replacing it. So I've taken a letter out, so I only have 6. And I look at, well, how many L's do I have left? Well, I have 1 L. So I have a 1 in 6 chance of then getting an L. Then what I do is multiply my probabilities together. 2 times 1 is 2. 7 times 6 is 42. I can simplify that a little bit because both of these numbers will divide by 2. So that'll be 1 over 21. And I can, again, get a decimal. It's going to be pretty small. It's going to be approximately 0.048 or 4.8%. So I hope that made sense. You may need to watch this again to really get the concept. But if you're ready to go on, let's try some of these. So I don't know why that keeps coming up, but there we go. Pause the video and try these 3 questions involving the marbles. Okay, now try these. Same thing, except now we're using the bag of tiles, like our last example there. Okay, if you're done with those, I got one more thing for you to do. I want you to imagine your name is in this bag of tiles. So write down your first name, and then imagine those letters from the bag of tiles, and answer those questions that follow there. And then when you're done with that, you are done with this, and you can move on to the next activity.